Okay, so today I'm going to start doing geospatial, and I know some of you were having issue with the website, the notebook, whatever, and don't panic. Anything that you encounter, I've encountered before. I know exactly how to resolve the issue. Just see me after class if needed. And one thing you can do the debugging is always check the website. So all the detail, if anything goes wrong, you will know. So just go to actions, find out whatever things that fail, and then just click the red check mark. Mine are all green, look great, but I also have green red arrows sometimes. Mine have that somehow. Okay, that means I know what I'm doing. All green, okay, but for example here, right? Just look at this simple stuff. If anything goes wrong, don't worry. Click and then go to see the details. It will tell you exactly why something failed. And then click here and you see blah blah, and then you there's some typos. Example, I tell you what is a typo or if the file is missing or anything. There's the reason why it failed. And whether the notebook is not in the correct path or something is missing or some typo, these are things that are good because it do basically the make sure that your repo is performed like some minimum requirement. So you remove the typo, remove anything that might not work properly, and then you know in advance. So again, don't worry if something goes wrong. Let me know. And if you ask questions, if you send to my email, make sure you always send the link. Make sure you send the link to your repo or to the error. Don't just say that, oh, I'm encountering an error. Yeah, I don't know because sometimes you're not giving me enough information. And I always have to log into Canvas to find out, oh, where's the repo, where's your package name. It takes me more time. So please, if you want to ask me questions, just make sure that you ask the question and then make sure I can easily identify the problem. At least send me the link to the specific error and then I can give you more information rather than have to guess. Sometimes not direct. Okay, so, and for today, we're going to start doing geospatial. So the last couple of weeks, we have like basically covered all the basics and teach you how to build basically the foundation of your house. And also show you kind of what kind of material we can use, like bricks, wood, whatever, like some of those Python basics. And starting from today, we're going to really build the house. I show you where to get started. Do you want to build the bedroom first, or the kitchen, or living room, whatever you like? And there's a way to do that. So today will be kind of a general workflow. How do you add things to your package, and how do you test it so that you know it is working as expected? So this first, I'm going to go through kind of the general structure so that you know what each file is being used for. So it's very important that you understand why there's a bunch of files in here, and there's a purpose for each individual file in here. And so let's see if I fold. So first, I'm gonna show you just for example in this is a root directory, right? This is a package. The first one here, .github. And if you scroll in workflows, these are all the files that has been created automatically when you use my template, cookie character template. So all these things are called GitHub actions. Basically, the virtual environment that you can create, track, and test your packages in different environments. For example, Ubuntu, Linux, right? Windows, and also Mac OS, and also how you deploy your website, blah, blah. We'll come back to this later, but right now, just for this is not part of the package. This is like outside the package that you use to testing your package. But when user install your package, these are not needed. This is yours for your testing environment. And then anything under the docs website, this is where the website is being created. So if you want anything to be included in your website, it must be placed within this docs folder. Don't, if you have something outside, for example here, or you have another folder called examples, it's not going to work. So anything for the website, it must be within the docs folder. Otherwise, it cannot access. So for example here, here's pretty bit here to see. Everything needs to be here. So the website is being built by the content in here and Also this one called mkdocs YML. So this one controls basically the navigation and also the URL, everything. So this one controls how your website is going to look like. This YML and also the docs folder is the website. Okay, again, website doesn't have to be part of the package. When the user trying to import your library, it has nothing to do with the website. The website is more like not the core of your package. Next one. So for my package name, it's called Geo here, right? So if you click this one is the real components of the package, the functionality of the package. So for you guys, you have a name, something, whatever name you really choose. And right now, I only have 3 files. So this is where all the functionality being hosted. You can add as many. So for example, each of those here, you can call one module for specific things. And you can put things in, you can put everything just within one single module, or you can create multiple modules. So it depends on how you want to organize. And it will be like something like this, okay? So for example, this will be the key to your house. And you can just like, as a single house, you have everything inside. Or you can, okay, this is the key to my house. And once you get to my key, you can get into my living room. You can get into the kitchen. You can get into the backyard. You can get into the garage. Whatever you like, you can have separate modules. Or you can just like one single one. You can get into just, for example, the football stadium is just a stadium. There's nothing else. So think about how you want to organize. And one thing, if you really want, you can just go to, for example, I can show you here. Maybe, how about this? Just for example, the leaf map, right? So I can show you what it looks like. Go to my leaf map repo here. And it's going to be the same structure. So all the packages are creating and using the same template. So for me, leaf map will be like in here. And look at this. How many modules do you have? You can have 10, you can have 20. You can essentially unlimited. So it depends on how you want to structure your package. Right now, it's perfectly fine. You probably have these 3. Okay, so the init and the common and also geo, whatever the main module. So later I'm going to show you how to add things to here. And then on another one is called testing. So this one is used to write continuous testing. So to test the package. And right now it's pretty just a simple basic one. We cover this one later this semester. So this is something that you can have, or you can also use the GitHub Actions to automatically do the testing. So the combination of 2, they can make sure that your package is function at its expected. Don't want to have something surprising like when the user tests on computer, oh, this doesn't work, oh, this doesn't work. No good. So this is something that we deal with later. And then will be like .gig ignore. I will show you later how to use this one. This one's basically you're doing the development. Sometimes you might have a lot of files there on your local computer, and you don't want to commit those files to the GitHub because, like I said, when you try to commit something, double check twice because you don't want to commit like 100 megabytes of the big file to the GitHub repo. Once it's there, it is there. It's like permanent. So if you have a large repository, when users trying to clone, they're going to download a large file. So make sure that you don't commit large files. It's not recommended. You're going to regret it. Okay? You're going to delete the one and then create another one. It's not going. You're going to save a lot, waste your time. And then this one probably you don't have pre-commit config. This is a little bit more advanced. It's also trying to check whether you check something before you commit. Okay, it's nice, basically a step that you use as precaution to mess up your repository. I didn't include this one in the package template, so you don't have this one for now. Forget about it. The license, this is what you chose when you create a package. It can be MIT license. It can be something else. It's empty. Not be empty. It's empty. Something is wrong. Is guys your license empty? Don't be. Probably I messed up. Empty on repo. It's also empty. Okay. Something is weird. I need to double check probably the template. It's not a big deal. I will show you how to fix it later. And then this one, manifest.int. So this one is when the package is being built. It's going to include what kind of files need to be included. For now, keep it as it is. You don't need to change. readme.md. This is the one that on the GitHub homepage. It's going to render using the readme.md. And then mkdocs.yml. So this is how the website is going to look like. Next one, iProject.toml file. So this one is super important. This one is the entry point when the user install your package. It's going to basically figure out how to install it, what kind of packages are required. And right now it looks pretty complicated, but this one tells you basically the metadata of your package. This one is a required one for any Python package. This is the name, this is the version, dependency, what kind of things it support, and also what kind of requirements. For example, here, this one shows you requirements.txt. This is the dependencies, and it's actually coming from this file here, requirement.txt. So later on, if your package is going to build on top of some other packages, you want to put something in here. But you also need to keep in mind is your package, the dependency, can work multiple across platform or not. It might only work on Linux or might only on Windows. Then you have to be careful, because if you put in here, then if user trying to install, if that package, that dependency doesn't support all the environment, it will fail. So you want to be careful about putting things in here. For example, you guys enroll in this class. I can put a prerequisite that you must have taken Geography 312, Intro to Programming in GIS. Then most of you will be out. You cannot take the class because you don't meet the prerequisite. Make sense? Or you don't have it, then you need to, in your code base, you make sure that, okay, even if you don't, for example, you didn't take 312, I still allow you to take, but they need to spend 2 weeks just to cover the Python basics. So similarly, in your package, you need to do something like that. If you don't include the environment, like package dependency, then you need to, in your source code, you need to check whether the user has installed the dependency or not. If not, you need to inform them to install, and then you can use something, right? So this, we covered it later, but for now, just let you know everything, basically, any dependency you want to add in here, and you only add the dependency that's being used quite a lot in your package. You don't want to add a dependency is only used once, and it's not really useful, and also that package might be, that dependency might like 100 megabytes. You need to stop by saying, is this really required? If not, don't put it. You in your source code, you inform the user to install if there's no install, because you don't want to like install. You don't want to install ArcGIS just to perform a bar for analysis using a data set. If it is only you're doing one single function, you don't need to install Gigabyte. You can just use Python. A couple lines, you can get it done, right? Make sense? So basically, anything they want to put in here, think twice and ask yourself, is this necessary? Last one, requirements underscore DV. So this one is basically some optional dependencies that user, if they want, they can install, or it might be something that you use during the development, but it's not specifically for this package, but it's more like the package that you need in order to, for example, to bump the version, to build the website or something like that to teach locally. You can have something in here. For example, all the mkdocs website. And this is needed if you want to build the website locally. I will show you how to do that later, but for now, most of you don't have to touch this one. So for this class, this lecture, we're going to modify some of these files. And I'm going to show you how you can add functionality into your package. Any questions? If not, let's start messing around with the package, right? As I mentioned, your entry point will be here. Geo, for example, is the name of your main package. And then you're going to have underscore init. You're going to have command. You're going to have this one. So what we want to do here, this is with your main package. So when the user import the name of your package, it's actually going to come to here. This is the entry point, the underscore init. This is the file that's being executed first when you do something. So here, and I'm going to show you an example to use the ipyleaflet. So ipyleaflet is a very popular Python package for doing interactive mapping. You're welcome to use other ones, but ipyleaflet has the a lot of functionality. So I'm going to show you here where to find it. You can just Google it, ipyleaflet. So ipyleaflet built on top of the JavaScript library called leaflet, and it's just a Python version. But you can also Google leaflet. Okay, that one is using JavaScript and HTML. So for this course, we are just using Python, but basically just a wrapper of the JavaScript library. And this is like, if you want to use JavaScript, you can use it something like this. This is the source code that you can use to create a map. Since we're using just Python, we can use this package called ipyleaflet. There are tons of examples. So we're going to use leaf maps throughout the semester to show you how to create a map, how to do things interactively, and how to add some functionality to it. If you have time, you can go through that. But minimally, I want to show you how you can start using this one. So if you go to the usage, of course you need to install the package. Okay, and maybe how about this map and base map? So let's look at this. Some of the base map in here. Some of base map. Or you can click the map. Right, there are tons of base map in here. By the maps. So imagine, assume that, okay, now you are interested in this package. You want to build on top of this one, right? And the first step will be you need to install this one. And you also need to make sure that it's available so that you can build on top of this one. And in order to do that, the first thing that you need to do is to come to your repo and then find this requirement.txt. You need to add the dependency in here. So ipyleaflet is a very lightweight package. It works across platforms. So because I already know, you can just safely add it in here. You may or may not have this one, numpy. It doesn't matter. If you have, keep it there. So just go to the end, hit enter, and then just type ipyleaflet. Double check, okay, make sure you don't have typo. Okay, and then Control S. So means right now you have added this one to your repository. And to be safe, I will create a new branch. Okay, create a new branch. Let me control a little bit bigger here. So under my terminal here, I will just git checkout -b, and maybe I can create a new branch called map. Git checkout -b and map. So right now we're creating a new branch that later on when we push to GitHub, at least you have some a new branch rather than directly modifying the repository. Once you have the leaflet, first step is to make sure that you have this one installed on your environment. If it doesn't, then you need to install it. I'm not sure. Most likely, if you have followed the instruction at the beginning of the semester, it's already have this one. But you can certainly use the terminal, or you can use your Anaconda prompt. You can install packages from here. So I can just keep install, and then -uppercase U, then ipyleaflet. Okay. Keep install -uppercase U, and then ipyleaflet. So this one allows you to install the package, install the latest version, and make sure that you conda activate your environment. Otherwise, you probably might install to your base environment. So conda activate the name if you don't see the environment name in here. Conda activate and then the environment name. Then just hit enter, and it should be able to install this one within a couple seconds. And you're going to spin very, very quickly. And after that, they're going to show you, okay, so right now, ipyleaflet has 0.18.2. I might have on older version previously. After that, you should have this one installed, and then you are ready to go. Okay, so previously it was 0.17, and now it's 0.18.2. You might see some red color here. Usually, these are some dependencies. Anyway, so those are, you can ignore it. Don't worry too much. It should not affect the functionality, okay? Then you can just type clear the output console. So now we have the ipyleaflet installed inside, and we can start writing some stuff to doing the testing. So all I would recommend is to go to your docs directory, and then under your examples here, you should already have some notebooks, okay? before we add functionality to your package, we can actually create a new notebook to just do some testing. So right click the examples directory and then new file. From here, you can give a name to your the notebook. I can just type maybe ipyleaflet dot ipynb, okay? ipynb, so ipy notebook. Then you want to create this empty notebook. And upper right here is to say, okay, select kernel. So you want to select the kernel that we just have ipyleaflet installed. So for me, it's the geo environment. So if you just select that, it should take a couple seconds to do all the checking. Hopefully, no errors or anything. If it gets stuck, if it like checking forever, then probably you might want to close your Visual Studio Code and restart. Once it's done, then the next step will be just come here to ipyleaflet and just copy any examples. So for me, for example, I'm under this maps and leaf map and maps. So for here, or maybe let me go to the uses, okay? From here, you should be able to see something like this. What you want is simply copy any code block from here, select, and then Control C, okay? And coming back to here, just Control V. And you should be able to see from ipyleaflet import something. There's a red semicolon here. This is actually a typo on the website. You can remove it. Semicolon is for JavaScript, not for Python. And you run it, the left side, see if it works or not. Works? Okay. Why it doesn't show? It should have a marker. Marker doesn't show. We remove. So it's pretty simple, easy to use. Basically, you create a map and then you have a center, you have blah blah center, zoom, add a marker. But I mean, for me, usually I would do something like this. We create a new code block, okay, and I can just say import ipyleaflet, okay, and then Alt Enter, create a new block. Then just m equal to ipyleaflet dot map, okay, perfect, 0. So here the center means is the latitude and longitude. For example, I know for the US would be 40, and then so 40 is latitude. I can do another one here. Longitude negative 100, and then zoom level equal to 4. On this one, you'll be able to see the map center around the US. Now, you see this one? Center equal to 40 negative 100, and then zoom level equal to 4. Then you should be able to you see this map? And if you use your mouse, it's going to go up and down, but you can use this zoom in and zoom out to see the map. Okay, so this is how you create a simple interactive map using ipyleaflet. And the other one you can use mdoc. I think it's called like view zoom or something. Control space. What was the name? Yeah, scroll wheel zoom equal to 2. The reason for this one is usually I like when my mouse is hovering the map, when I want to use my scroll, I want to zoom in and zoom out the map rather than it doesn't do anything, go up and down. So if you enable this one, mdoc scroll wheel zoom, you run this one again. Okay, I'm going to create a new map. So now if I use my scroll, that little bit better rather than you have to use the mouse to click here. So now if I zoom in and zoom out, it should be doing like this. Okay, simple and easy, right? So this is how you, for example, create a simple map. But if you use the default one, if you don't do anything, by default, it will be like this. So import ipyleaflet and then m equal to ipyleafmap.map and just m. And if you run this one, it will be just a simple map. Looks like this. So it's centered around 0 and 0. And it's just showing it looks like an empty map. So you have to zoom way in. I don't know. Let's use the default one a little bit better. But the code that I used is this. So now, right, I can create a map actually a little bit better than the default ipyleaflet map because you can customize it. So next, let me quickly show you how do we actually add this one to our package so that the users can use our package to create a map. And then by default, you're going to show something like this. And also, you're going to enable this scroll wheel zoom rather than you have to do that on your own. Make sense? So next, let's come back to here, to the name of your package. And then the name, the package .py. Right now, it's empty. There's nothing in there yet. So we can do something very similar. So usually, the workflow of doing the development, if you build on top of other packages, is that you first testing something using your Python script or using the notebook. You know what you are expected to use. And then you can come back to reorganize and then put it into your package. So right now, this is the main module. Okay. So what we want to do is to actually create a new map class and then inherit from ipyleaflet map class. So first, you need to actually import a library, right? Import ipyleaflet, put in here. Okay. Then, very much similar to the ipyleaflet, we're going to inherit the map class. If you really want, so basically the next couple of weeks, I'm going to show you how, for example, leaf map was created. So if you really want, you can go to the leaf map and then look at the leaf map.py and you can look at how it was developed. So at the beginning, you're going to import a bunch of packages, and then you're going to see here class.map, right? ipyleaflet. And then you're going to have a bunch of like default parameters. Then you're going to create a map. So it gets pretty complicated, but this is essentially how you build on top of others. And depending on how many lines you're going to write, you can get like thousands or tens of thousands, 5,000 lines, right? Just to build on top of those, you can add a lot more functionality. So here, let me show you like how do you build on top of the map class. So what you want to do is to just type class, and then you're going to create a new map class. Your map class is going to inherit ipyleaflet map, okay? And after that, colon, hit enter. So we're going to inherit from the map class, and if you have Geographic Copilot, it should show you how to do that. But there sometimes might be too many, right? You can see, wow, pretty impressive, right? How many lines? I don't know. It's a little bit too much. So if you have nothing, I can just hit tab. And what I'm going to do here is to remove other stuff because I don't need that many complicated stuff. But I do want this first one. If you don't have Giga Copilot, you need to write it df underscore underscore init underscore underscore. So if you remember, this is the one that we need when you define a new class, because this is the first one being executed. And then it's going to, for example, when you create a map, it's going to do this super dot underscore underscore. So the super means is the parent. So basically it's the ipyleaflet. And what we're trying to do here, basically, we're build on top of this map class. Whatever parameter you give it to me, I'm going to pass into the ipyleaflet map class. And then it's going to create a map. And the map has a handle called self dot something something. I can also remove this one. Okay, add control, whatever. And just control S. Yeah. You can have this one or you don't have to. It's don't worry about this one, right? So the add control basically allows you to add a layer control. So the layer control looks like this. If I go back to this map in here, and let me show you map.add control. ipyleaflet full screen control all the layers control. So we have this one here. ipyleaflet.layer control uppercase, and if I run this one, it's going to look like this one. So this is the layer control. Right now, it's only one layer, so this is the base map. So it's going to show you like this. But you can also show the control. You can put it in the upper right. So usually for me, I don't want it to be on the left. I can say position equal to top right. Control enter. And it's to create a map and then put it in the, oops, or X control. Or maybe it's in here. No, this one. Okay, I will show you later. For now, just use the default one. I don't want to waste too much time here. So right now, after we create a map class, and we can test it. So this is the most basic. There's nothing really much going on. So what is just create a simple map and then add a control. So how do we test it, right? So we can come back to the source code here. And before you can test it, you need to make sure that you install the package, because we have made some changes. And you need to make sure that you install this one to your environment. Otherwise, you cannot use it. So pay attention here. This is something like sometimes if you forget, you will say that, oh, I already add the function. It doesn't. Why it's not available? So the reason is because you haven't installed it. So come back to here and make sure that you are under this environment and under the package repository. So what you need to type is this one: pip install -e space serial. Okay, pay attention. This is the one that you need to do. So what this one is doing is we're going to install the package to our environment, and we're going to basically not install it. It's basically linking the file to the repository that we are working on right now. So the serial is the current directory. Basically, it's going to install this package right now under in here. And if you don't have the -e, it's going to copy the file and then put into the environment. And that's going to be an issue because if I'm making the changes, the file are not being copied. The -e is basically install this package, but link the file in this repository. Otherwise, the package will be installed in here. Let me show you where it's being installed. So if you go to the C drive, under like, where is it? Under your username. And then your user. Miniconda 3. Accumulate. View. How you, let me see if we can control. Okay, anyway, doesn't work. So Miniconda 3 and then EMVS. Okay. And if you click, you should see this one. So for me, it's a geo environment. So when you create the environment, whenever you install package, it comes here. Under this, the name of your environment, and then you will be under lib lib. It's kind of hiding. There are many labels. Okay. And lib, after that, you will be site packages. Okay. Everything is come to here. All the packages that we install to the Conda environment is under your username, Miniconda, EMVS, and the name of your environment, lib site packages. So everything is to be under here. And for example, if my package name is called Geo here, I'm not sure if this here or not, GEO. Yeah, for me, it's not here. It's not even installed yet. So what we need to do is to install the package, but it's not copying the files in here. It's basically linking the file to my current directory. So this is the command that you need to have, otherwise it won't work. So pip install -e and then serial. Let it run. It might take a couple seconds. So what we're doing here is to actually install it to the environment. But whenever you are calling importing the package, is looking at the file under this current directory. The -e is the one indicating it's doing the linking rather than actually copying the file. So it's going to install the dependencies, and dependencies is basically a requirements.txt. So this is the file that we use to install the package. Mine is a little bit slow, but for you guys, it should be pretty quick. You working? Hopefully it'll be done. And if you want, you can check the in here to make sure that if you can see the file. So for me, it will be geo hey doesn't show up yet, but when it's done, you will see a directory somewhere under here. It's basically the name of your package, but it doesn't really have any file real content in there. It's too slow. Okay, building the wheel, blah blah, successfully build, and then it should be done. Let me open this one more time. Okay, not really. The recording is taking too. Anyway, but you can look at it after you install. Now the package is available for us to do the testing. So here, done now, and I can come back to my the notebook that we just created earlier. I can show you. So from there, you can start importing the name of your package. For me, I will be import geo. Okay, you see that? Yours will be the name of your package, whatever name that you chose. And so enter. To be done now. And there are two ways you can do the testing, okay? Because when you are importing this geo here, it's going to import this one. Right now, there's nothing really much in here. So what you need to do is something like this. From the name of your package, geo here, import map, okay? Because this is the map class. Oops. Oh, sorry. Be like this. From geo here to geo here, import map. Right now is a little bit inconvenient yet. The reason for this one is if you look at your repository, right? So this is the name. So when user use the import geo here, it's going to look at this underscore in it. But our map class is actually under this one, geohe.py, and this is why you need to use the name of your package, your name of package, and then import map. Later, I'm going to simplify that. For now, just going to show you like if you don't do that, this is what you need to import. And after that, I can just m equal to map, okay, and then map. Run it, see if you can get the map. Okay, so by default, it's going to look something like this. But we at least we have the layers control, right? I can allow the user to specify. So it will be center equal to 40 negative 100, and then zoom equal to 4 1. So you can customize the center, the zoom level, and also you have by default this layer control. It comes from here. Or because earlier by default we don't actually provide any parameters. So when the user creates this map class, if you press Control Enter or something, you don't really see the parameters in here. So all the parameters that we provide in here, it can be passed into the ipyleaflet map class. So to make it easier or more specific, you can do something like this. So like here, I can just say center equal to parentheses, square brackets, and I can do latitude 20, longitude 0. I can do a zoom level equal to 2. So what this is doing is when I create a map by default, I can specify this center and the zoom level. And this, if you see anything grayed out, that means your source code is not being used. So you need to be careful if you see any gray color being, any text being grayed out. So what we want to do is to pass this center into here. So if we center equal to center, zoom equal to zoom. So what this is doing is whatever center or zoom level that you give me, I'm going to pass into the ipyleaflet. So basically modify the by default behavior of ipyleaflet class. And then Control S. Don't worry if you cannot catch up. You can just go to my repo. We can copy that later. So here, now we have changed the default behavior. And let me show you, right? Right now I can so anytime if you're doing the testing, you need to make sure that you restart your kernel. And so right now, if I import this library again, here, this time I can remove this, okay? I don't want to provide it. So if you don't provide, it's going to use the default parameters. If you hover your mouse, look at this. So if I hover my mouse, do you see this now? It's actually going to show you the default parameters. So if you don't provide, it's going to look like this. So now if I click one, see, it's going to create a map default at this map view. So center around latitude 20, and then longitude 0, and then zoom level 4. Of course, you can change it if you want to, but we also have the default layer control in here. Make sense? But as you probably noticed, this looks a little bit weird. Why you have to do like the package name, package name, map? Yeah, the reason because if you want to simplify it, you need to basically import things from here. So what you can do is to, let me show you, for example, what it looks like on the leaf map __py, right? So by default, when user import leaf map, I can just this should be something at the bottom here in from from blah blah import star. So what this one is doing is by default, when the user import a library, you want to import everything from the main module. Okay, so let me come back to here just to show you why we want to do this. Because if you don't, user have to go to the package and then go to this module and then go to this map class. But if you put under the init __, then it's going to be automatically import everything. So what we can do here will be from .geohe import map. So basically, we are moving the map class to make it expose the map class under this main __ in it, so the user don't have to do something like multiple one. So you can either import a specific one, or you can just use a star. So use a star basically means you add everything under the main module. If you want to expose everything, then you use the star. If you just want to expose the map class, then you use the map. So Control S. So now we have this map class being exposed in the main module. So now if I come back to here, I can just simply do import geohe. And now I can remove this one. What we can do will be like this, geohe.map. So this will be similar, import leaf map and then leaf map.map. So we're doing the same thing here. Again, you need to restart the kernel, clear all the outputs. And if I click this one, hopefully it works. See? Make sense? So you're exposing the map class under the main module into the default package. So this is __ init is the entry point to that one. And then geohe means under the current directory. Get this. Okay. Again, make sure you understand the logic. When user select import geohe, it's going to come to the package repository, package directory, and then go to this in __ init this file. And this file, when it's executed, it's going to look for whatever things you put in here. So you say, okay, go to this file, get the map class, and then make it accessible. So basically, it's going to go to this file, grab this map class, and then make it accessible. This is why in here, Now we can just use the import geohead and then geohead.map, and you can start doing all kind of things in here. So this is the simple way to inherit a map class and make it accessible. So once it's done, I can quickly, okay, I'm going to say Control S. I'm done with this one. I've added the map class. Of course, we're going to add a lot more things over the next 3 weeks. But for now, okay, this is just the simple things that I have added. And again, look at the repository. Look at the files that you have changed, and try to click and make sure that there's no obvious error, right? This looks okay. The requirement.txt, also the ipy notebook will be this one here. I can make it a little bit simplified. So let me remove all the unnecessary content. I just want to have this. Okay, Control S. Then I'm done. So I'm going to just push this to GitHub. I can just say add map class. Then Control Enter. It's doing the tracking, but hopefully no error messages. Then oops. Okay, the reason is because I have that let me pull this one and Control Enter. Okay, then push the branch. So then right now, basically we have X some functionality, and we push to GitHub. After that, you can go to the GitHub to get it. Go to my repository here, and it's going to show you. You should have a new branch. You can compare, submit the pull request, and look at the files that you have changed. If you want, you can write something here. So add a new map class, Python, port, okay, and go to map, like this, just to make it more descriptive. And after that, just read the pull request and take all the testing run. It's going to take a couple minutes. Once it's done, if it is green check mark, then you can just merge this. And I know probably this is a simple one, so it's not going to may fail or not. But again, I don't have time to wait, so I'm just going to merge this one into the main repository. Okay. So after that, now I should have see these files in here. Okay. So I have this new map class, and then locally, this is what I need to do, right? After that, I can just git check out main, so basically the main branch. Okay. Then I just git pull. You pull the new changes that you just merged. Then you can continue to work from there. So this is more like the general workflow. You see here, everything now should be available in your main repository. And you can continue to add more stuff and then use the notebook to do the testing. Once everything works fine, you post to GitHub, merge, basically kind of a cycle. So this is general cycle. And then once it's ready, then you can just create a new version. And then bump the version and then release, and then it become available, you can install, you can test it. We continue in the next lecture, but this is just the basic workflow. Shows you how to build on top of other packages and then add a simple stuff, and you can customize some default functionality. Yes, we can do that in here. Yeah, be next next week or next week. Okay, so it's over time. That's over today, and we'll see you next the next lecture.